Okay, so here we are at point 4 and part 4. Point 4 means that we're at a point where we're very close to staging the processors. The heat sinks have been cleaned. The secondary processor is depopulated, and we do that on purpose. And the reason why is to make sure that it is not part of the initial test power-up sequence. We have some basic RAM in there, and sitting over here is the second processor. And as you can see there, you're dealing with a 20, let's see, this is I believe it's a 2640? I'll have to check. Anyways, the point is that processor is standing off for now as we basically get the core processor, i.e. CPU1 or SP1, operational, and that the BIOS can boot, which is the whole reason why we had to replace the motherboard in the first place, because the BIOS posted and stuck itself pretty badly and would not recover. So with that being said, I double check all your 4 base RAM modules, which is basically 4 gig units that are in there right now, to see how it's going to come up and operate. I'll be pausing the video to get the heatsink positioned, linked up correctly, and on board. Now, in regards to the thermal paste, and one other tiny detail about this motherboard, sometimes you will find this motherboard will curve up back here. And don't make the mistake of trying to force everything on, because it won't work. This fan assembly will not come down correctly. It just won't work. Second thing about this motherboard is that because of its length, it's flexible. But if you use the NICs, like I told you, the NIC attachments to straighten out your pathway, then your power supplies will connect in correctly and the fans will drop in correctly, and it's flush against the base of the chassis of the server chassis, or the bottom of the server chassis. So at this point stage, I'll pause this, put the heatsink on, get our power and connectivity up and running, and see if we can post the motherboard. Be right back. Okay, one small detail here also to remind you of is the nature of how these heatsinks go in. You can only turn them about 5 times on each side because they're basically slowly smushing your thermal paste into place. And by doing that correctly, you're not actually distressing the processor or the mount and so on and so on. So the key thing here is to make sure that you're turning them side to side. Now, one other very important detail, this is standard industry thermal paste that is rated for servers. And what all that basically means is, because it's rated for servers, means that it's not going to degrade to the heat. Don't use liquid metals on Xeon processors. You're dealing with a whole different heat level, and that is a real potential risk to your system, and as well to your ability to maintain the correct electrical connectivity, because liquid metals can, regardless of what anyone says, can be at risk of getting down into the mechanism and frying everything. Thermal paste does not give you that kind of a risk on a natural basis, so it's out of the equation, and that's a good thing. But at the same point in time, understand, as much of a potential benefit you think it's going to give you, it really won't. So stick to the industry standards for thermal paste. All right, give me a second here. I'll get power and everything hooked up, put a shield in, and we will basically get everything up and running. Okay, so as we stand here now, we have the core processor in place, everything's in place. Now we're going to start the process of putting the lid back on and then using that as an air vacuum control so that we're keeping everything nice and cool, mind you. And we are going to power her up. Okay, we have post and power. We hear fans, and we're getting something on the screen. Now this is a lot farther than the other motherboard that died. So this also should be coming up as a Dell OS opposed to a Google OS. Now this is not the cheap way to get past the Google OS, but if the motherboard is dead when you get it, the chassis is absolutely worth $100 or so to get a replacement motherboard like I did, because it's just so valuable. The dual drive set in the back, all of this processing power here, extra I/O slots, you name it. And then over here on the front, look at all those discs that you can handle. All in a simple 2U footprint, and it will do the job. So here we see it posting, and we want to go into the system setup to take a look at what's going on inside. It's beginning the process of posting. We see the RAID controller. That's excellent. We see that there are no values for drives. By the way, something you might want to consider doing is grabbing one of those SSD Dell drives for $60-80. Throw that in as your cache front-end drive. You can use that as an SSD buffer. And a 100 gig write cycle means you could transfer up to 100 gigs actively at a very fast rate because you're using the SSD as the front end. Now over here, as you can see, we still do not have our second processor installed. But we do show here that it's ready to go into setup. So I'm going to hit F2. And we're going into what I hope is a Dell BIOS. And there she is. I have access to everything. The iDRAC is cleared. Everything is operational. Excellent. This is a powerhouse. So give me a moment here and I will go ahead through the process and basically add the second processor, and we should see two processors, the additional cache resource and the additional RAM resources at our disposal. So give me just a minute. Okay, so now we have the second processor on board. We have the first processor on board, and these are just lightly warm. They're not hot at all. So that means my airflow is doing really good. I still have some potential risk of loss of airflow to some degree. But frankly, in my opinion, the fillers don't do a great job. All they do is just kind of straight line the airflow. So as long as this is not messed up and not clogged full of dust particles, you're going to find it pretty sufficient to being able to move heat out of the area. And it's not really about how the fins get airflow, because that will happen because of the heat. It will happen because that's the nature of heat in convection, is how the heat will actually escape. So what I'm going to do now is I'm going to go ahead and close her up again. I'm going to post her on the OS. We're going to make sure we see more memory, more processing power, and everything is coming up correctly. All right, hold on. All right, so we've got a process getting ready, and we're powering up. We'll make sure that everything is posting well. Yep. We're seeing what we need to see. This is good. Sometimes when CPUs give you difficulty, they can knock out controllers and other interfaces specifically related to DMSing or DMA, direct memory addressing, that's in the equation of getting resources to processing resources. So we want to make sure that the I/O stacks are coming up correctly. In this particular case, the NICs and the RAID controllers, those are separate processors that will ask the primary processors for resource through the PCIe bus. So we're going to watch that right now and see how that comes up. Good. We're getting a good posting. We're going to go into okay, good. We are entering. There's the rounds of NIC cards. That's good. We have a train failure, an FTPTM on DIM A4. I'll check that out. But it won't stop it from working. It will just isolate it and keep it out of the equation. There are the other components, the Ethernet boot controller, the RAID controller. It's posting the RAID controller. I'm not seeing any virtuals as it was before, so no change. That's good. Resources are getting allocated. We are getting some call errors, which is to be expected. And we will go into F2 and see what's going on. So once we get the BIOS to come up and report that we are happy, and that's a good thing, we'll turn around and I'll work on some of these issues here which we have out there, and basically allow the system to be able to do what it needs to do. But I think really much for this video, or the series 4-part video, this chassis is good to go. And now I've got myself, instead of a Google search engine, I've got a Dell 720DX ready to go. I hope you enjoyed this video. I do these videos because people out there can't afford to learn these kind of things because it costs so much money. And that's not a joke. And so anything I can help to share the knowledge and get you guys to enjoy technology as much as I do, and give a little bit back, be helpful to other people and helpful to other things, so on and so on. But God bless, and I hope you guys will enjoy the video. If so, give me a like. If not, give me some comments. I can work with it either way, and I'll let you go. Thanks. Bye.